So the more difficult type of question will be, we have the two types of graph together. So in this example, we got both the distance time graph and the speed time graph. So I will suggest, again, right, you write the feature first, write the feature for the distance time graph, taking note of the units. So this will be the speed. So when you are doing distance time graph, the gradient is the speed. Okay, so let's try to answer the question right now. Okay, based on distance time. So do not get confused by the speed time that's in the second part of the question. So in this case, I will need the gradient for the first 6 seconds. So again, you take the vertical distance. So the vertical distance is 30 meters. The horizontal distance is 6 seconds. So the speed is 5 meters per second. Okay. Then the next thing is I would like the acceleration at t equal to 2. So what is the interpretation? So at t equal to 2, it is a straight line. So the straight line means constant speed. So it is at a uniform or what we call constant speed because it's a straight line. So that was what we mentioned in the distance time graph. If you got positive gradient or negative gradient, it's a constant speed. So in this case, right, in a constant speed, that means they got same speed throughout. So you didn't increase the speed at all. You just maintain at that speed, and which in our case is the 5 meters per second. So there should be no acceleration. So you cannot tell from the graph directly. You got to interpret from the graph. So in this case, the acceleration is 0. There's no acceleration at all. Okay. In the third part, we will like the average speed. So we will like the average speed from t equal to 12 to 20. So if you think about average speed, running out of space here. So I will need the total distance over the total time. So we're going to explore this timing. How much distance was covered in this timing? So if you explore, right, 30 meters was covered in this timing. And the timing is 8 seconds. So from here, that will be the speed. So I'm answering A, B, C based on a distance time graph. Okay, the challenge is the last part where we are actually converting the distance time to a speed time. Okay, so I'm going to erase the whole thing. So make sure you already gotten all the answers. Okay, so in this, so I'm going to convert distance time to speed time. So what should I be converting? I should be converting based on gradient because the gradient represents speed. So the conversion will be based on the gradient. So like for example, just now, this part, we discover that the gradient is 5, which means the speed is consistently at 5. That means for the 6 seconds, right, the speed is constant at 5. They maintain at 5 meters per second for the first 6 seconds. So this gradient is 5. The speed is 5. Here, the gradient is 0. That means it's actually resting, so there's no speed at all. And then subsequently, this is a curve. I wouldn't be able to convert the curve, but the question gave us some information. At 20, the speed is 8. So at 20 seconds, the speed is 8. And they increase uniformly, meaning it's a straight line. So if I'm going to convert distance to speed time, I'm using the feature of gradient to convert. Okay, so that's one of the conversion that you actually need to understand. Okay, so subsequently, I also need to be converting speed to time the other way around. So in the next example, I'm converting the other way around. Okay, so let us try to answer the question first. So if you are worried, okay, let's write down the feature first. So the gradient is the acceleration. So the area under graph is the distance traveled. So for the first part of the question, I would like to find the speed when t is equal to 9. So this will be the method of either similar triangle or gradient. So that's your choice. So I'm going to show similar triangle. So it's not necessary for you to draw out. I'm showing the drawing out so that you can see it clearly. So you take the ratio of the height ratio and then the base ratio. Then you do your cross multiplication. So the speed is 12 meter per second. So this is like one of the previous example. Okay, and then find the value of V if the total distance covered is 900. So again, this is a feature of the area. So the area is 900. So where does the 900 cover? The 900 is here. So the 900 will be something like this. So I will calculate the triangle first. Okay, half times base times height. Then I'll calculate the trapezium. This part is the trapezium. So it'll be half. Okay, I think I run out of space. The height will be 40 minus 50. The parallel will be 20 and V. So from here, we form the equation. So 150 plus this will be 900. So you do your own equation solving. I think it's quite easy. You just have to be careful. You will get V equal to 40 meter per second. Okay, you go and do it out yourself. So this is making use of the feature of area under graph. Okay, then the next one, I'm going to find the retardation. Retardation is another word for deceleration. So which means, right, you will like the gradient. So I will like the gradient at t equal to 50. So how are you going to find the gradient at t equal to 50? You can find the whole gradient because it's a straight line. So some of you may be thinking, oh, I must find the speed here, then I can find the gradient. No need. You can just find the whole gradient. So the retardation will be the deceleration. It's the same idea as deceleration, how fast you are slowing down. So which is actually the gradient. So you can take the vertical. The vertical will be the v that you have found out just now. And then the horizontal will be the 20. So it's 2 meters per second square. Okay, so at the end of it, we are going to do the conversion. So which feature I'm going to use to convert? Okay, because I need to convert to a distant time, I'm using area to convert. The area is the distance. Okay, so I'm going to erase everything else. So I'm going to erase everything except the distance part. So just now we discovered that this is 150. Okay. Okay, the trapezium part, right, you will get 750. Okay, how I know, right? Because the total is 900. Okay, so how do you convert using area? You got to calculate the area part by part. Okay, so the conversion has to be done using area. So step one, you calculate each piece of the area. Okay, each section. So I also got to calculate the triangle here. So this one is half times 20 times 40. So that actually gave me 400. So step one, you calculate the area. Step two, you got to plot the points. The point will be time and distance. You can see this one is the time and then this is the distance. So the coordinate will be time and distance. So how do you plot the time and distance? So 15 seconds. The distance is 150. 40 seconds. The distance is 900. That means by 40 seconds, you already travel 900. 60 seconds, you have traveled everything, which is 1003. So you got the 3 coordinates. So you get the coordinates and then plot. You get the coordinates and then you plot. So I will get here, here, and here. So obviously it must start from 0. Okay, so the last part you need to join. You got to join based on 3 feature. So I'm going to show you the 3 feature. So step 3, you're going to join. There are 3 ways of joining the points. Okay, the first way is an increasing speed. So if it's increasing speed, it will be like this. So if it's a constant speed, you will join the point like this. So if it's a decreasing speed, you will join like this. Okay, so this will be the main 3 steps. I'm going to show the joining right now. Okay, so I'm going to show the joining. So this is an increasing speed. So the curvature will be like this. This one. This is still increasing speed. So it will just be another. And then apparently this is a decreasing speed, slowing down. So it will be like this. So you got to indicate each of the coordinates and then how you join them. Okay, so that's one of the more difficult conversion. And that's one of the more popular question during exam.